Hello everyone, welcome to Miss Molecule classes. In previous video, I have discussed about some important compounds which are acting as oxidizing agents and reducing agents. In today's video, let me discuss about some important compounds which can act as oxidizing agent or oxidant and reducing agent or reductant both. So now I'll take an example which will act as both oxidizing agent as well as what it is reducing agent. First I'll take the example HNO2, then SO2, H2O2, hydrogen peroxide, O3, aluminium oxide, Al2O3, chromium oxide, MnO2, zinc oxide, copper oxide. So these are the examples which will act as both reducing agent as well as oxidizing agent. So let us understand the meaning of oxidation number now. What do you mean by oxidation number? It is defined as the number of electrons. It is defined as number of electrons lost or gained. It is defined as the number of electrons lost or gained by an atom of the element. Atom of the element is termed to be called as oxidation number. For example, sodium, it is going to loses its electron to give +1 oxidation state. It has lost 1 electron here. And consider copper 2 plus ion, it has gained 2 electrons to give copper metal here. So which means that the atom of an element here losing an electron and here it is ion is gaining an electron. So here +1 is the oxidation number for sodium and here +2 is the oxidation number for copper. So what is an oxidation number now? It is number of electrons lost or gained by an atom of the element is termed to be called as oxidation number. You should be knowing that the oxidation number is also termed to be called as oxidation state. Now we can use the term oxidation number or oxidation state, both are one and the same. Here where the oxidation state can be either positive value or it can be negative value or even it can be a 0 or sometimes fraction also. So we can have the values like such as +1, -2, even 0 sometimes, even sometimes 3/4, +1/2 like this. This can be what it is. Oxidation state or oxidation number can be positive, negative, 0 or it can have a fractional values also. Okay, now let us understand rules for calculation of oxidation number. So there are some rules to calculate the oxidation number. Let us discuss them one by one here. What is the first rule here? The first rule is that oxidation number of an element, the oxidation number of an atom in their elementary state or free state or allotropic state is always what it is 0. I'll consider example for that one, for this one, so that you can understand easily. Consider the example here, sodium which is there in the atom form, and here copper which is there in the atomic form, iodine, chlorine, oxygen, or some of the elements in the form of molecule, because they will be existing, they will be having a stability only when they exist for it is molecular form, as such as hydrogen molecule, nitrogen molecule, chlorine molecule, bromine molecule, and carbon in its form, and zinc metal ion. All of this in their elementary state, they are going to exhibit oxidation state of what it is 0 oxidation state here. So now what is the second rule here? In complex compounds, oxidation state of neutral molecule is 0. I'll take the example for this one here. Consider carbon monoxide, which is a neutral molecule, so its oxidation state will be totally, the oxidation state will be what it is, 0. And I'll take another example. NH3 molecule is also neutral molecule and its oxidation state is 0. And another example, water is also a neutral molecule, so its overall oxidation state of a whole molecule will be again 0. So this is the second rule for calculation of oxidation number. Now consider the third rule. In general, oxidation state of hydrogen is always +1, but only in case of metallic hydrides it is -1. Let us understand this metallic hydrides later, but first I'll consider the oxidation state of hydrogen is +1. You can observe, I'll take the example for this one. Consider HCl molecule, hydrochloric acid. In case of this one, hydrogen is going to have +1 oxidation state. In case of H2O molecule, again hydrogen is going to have +1 oxidation state. Though there are two hydrogen atoms here, but each hydrogen is going to have +1 oxidation state. But now let me consider this metallic hydrides. If I consider the metallic hydride such as sodium hydride, so here the oxidation state of hydrogen will not be +1, it is going to be -1. What is the reason here? You should observe here, when you compare sodium and hydrogen, among the two, sodium is more electropositive. Sodium is more electropositive, and you should be knowing it's a metal. So metal are always ready to lose the electrons, they will never gain the electron. Metals are never going to have a negative oxidation number or negative charge on its atom. So sodium is more electropositive means sodium should get the positive oxidation state. Henceforth, the hydrogen is going to have its oxidation state as -1. It is only in rare example, only in case of hydrides. Only in case of hydrides, hydrogen oxidation state is going to be -1. I'll consider another example for this hydrides. Calcium hydride. In this case also, calcium is going to have +2 oxidation state, whereas hydrogen oxidation state is -1. So what you have to observe is that hydrogen oxidation state generally it will be +1 only, but only in case of this hydrides it is going to have oxidation state to be -1. So this is third rule. Now consider for the fourth rule, very important rule because it is purely related with respect to oxygen. In general, you can observe, in general, the oxidation state of oxygen is -2. Consider example for that one. If you consider water molecule, in this case, oxygen is going to have oxidation number as -2. Consider CO2 molecule, its oxidation state is going to have -2. So generally, if you observe properly, generally the oxidation state of oxygen is -2. But let us consider in peroxides. In peroxides also oxygen bonding will be present. I'll consider the example for this one. H2O2, hydrogen peroxide. Let me have a structure for this one. H here, O, O, and here hydrogen. So whatever this OO linkage is there, oxygen linkage is there, it is termed to be called as peroxide bond. In this oxygen peroxide bond, the oxidation state will be always -1. Peroxides oxidation state is going to be what it is, -1. One example is H2O2. I'll consider another example, Na2O2 and BaO2. So this is very important because you have to remember these example. You have to by heart and remember the example for peroxides because its oxidation state to be -1. And in superoxides, for this I'll take another example. In superoxides such as KO2, potassium superoxide. In this case, again observe this potassium is electropositive element, so it should going to have what it is, positive oxidation state. Oxygen is going to have minus oxidation state. The oxidation state of the superoxide is -1/2. Very important example for examination. And in case of, let us consider, in case of oxygen difluoride, let me write the formula of this oxygen difluoride. So you can observe oxygen oxidation state in this OF2 is going to be how much? You can expect here positive oxidation state. So you might be thinking that oxygen is never having plus oxidation state, but here it is going to have a plus oxidation state because of the reason is that fluorine is more electronegative. Fluorine is more electronegative element than compared to which one? Oxygen. That is why fluorine cannot have positive oxidation state. Henceforth, oxygen is going to have positive oxidation state. Oxidation state for oxygen is positive, that is +2, where fluorine is going to have -1 oxidation state. Remember, fluorine can never have positive oxidation state because fluorine is the more electronegative element among the whole periodic table. That is the reason. This is the fourth rule. Now let us consider the fifth rule. In general, oxidation state of alkali metals. What do you mean by this alkali metal? First group elements are termed to be called as alkali metals. Their oxidation state is going to be +1 always in if they are attached to any of the non-metal or metals. Okay. And alkaline earth metal oxidation state is always +2. I'll consider the example for this one. You can consider for alkali metals such as sodium, potassium, rubidium, cesium. These all going to have oxidation state to be +1 always. And these are termed to be called as alkali metals, first group elements. Even lithium also, alkali metals. Whereas calcium, barium, okay, then you can consider magnesium. These are always going to have oxidation state to be +2. I'll take the example for this one. Magnesium chloride, MgCl2. In this case, magnesium oxidation state is +2. Okay, this is about which one? This is about fifth rule here. So now consider for the sixth rule now. What is the sixth rule? In general, oxidation state of halogen is -1. Halogen, which are the halogen? 17th group elements such as fluorine, chlorine, bromine, iodine. These always going to have the oxidation state to be -1. But when they are having interhalogen compounds, it is going to have a positive oxidation state. What do you mean by this interhalogen compounds? The same halogen and halogen are going to mix up together to give a interhalogen compounds. I'll take the example here, IBr3. Okay, IBr3. In this case, iodine is also halogen only, bromine is also halogen. In this case, here iodine is going to have oxidation state of +3, whereas bromine is going to have oxidation state of -1. Again, the reason is that whatever the elements which is having a lower electronegativity is going to obtain positive oxidation state. If you compare fluorine, chlorine, bromine, iodine, you should be knowing as we go down the group, what decreases? Electronegativity is going to decreases. Henceforth, you can observe this bromine is going to have a more electronegativity, whereas iodine is going to have a less electronegativity. That's why positive oxidation state comparatively. But in most of the cases, the oxidation state is going to be -1. But when it is interhalogen compounds, it can have a oxidation state to be positive and it can range up to +7 also. Next, what is the seventh rule here? Oxidation state of fluorine is always -1. Remember, fluorine is always -1. Never is it is going to have plus oxidation state because fluorine is most electronegative element in the whole periodic table as I have explained previously only. I'll consider the example hydrogen fluoride. In this case, fluorine oxidation state is going to be -1. Whatever the compounds fluorine is attached, its oxidation state is going to be always -1. Consider the eighth rule now. Sum of oxidation state of all the atoms in a neutral molecule is 0. I'll take an example for this one to explain this. Consider NaCl, okay, NaCl compound, or consider calcium carbonate. So you can observe here there is no charge on this whole compound here. If there is no charge means it is understood it's a neutral molecule and it is oxidation state is going to have 0. And consider here calcium carbonate. Here the charge on this whole molecule, there is nothing means it is understood it is 0 only. So what is the eighth rule? Sum of oxidation state of all the atoms in a neutral molecule is always 0.